So the main difference between permutations and combinations is that in a combination, the order does not matter. So as we get into getting ready for our exam, when you read a question, you're like, ooh, I have to count something. The first thing you're going to ask yourself, does the order matter in this question? Should I go to my combinations route, or should I go to my permutations route? And then there's going to be some that they do both in the same question. Yay. Okay. We've already learnt the symbol. There shouldn't be a line in there. This is the one that we use for combinations most often, the NCR. You'll also see some textbooks that have the N over R in brackets. You have some special cases. Okay? Here we go, NCN. If you have, here we go, 52 cards. And the order doesn't matter. And I say, pick them all. Good job. How many ways can that be done? Right? It's one way. It's not like, ooh, I got a different deck of cards now because I mixed them up. You have 52 cards. You choose them all. There is only one way to do that. If there's 52 cards and you choose one of them, right? How many ways can that be done? Choose a card. How many ways can you pick a card? 52 ways, right? Okay. Quickly. You now saw all the cards. What card is missing? Well, I'll do it again. Ready? Pay attention. I'll show you 51 cards. What card does he have? You don't know? Oh, let me do. Oh, I was going to do it. You ruined my card trick. Okay, it's much easier to do a card trick if you tell me the answer than it is if you don't tell me the answer. But yes, it was the 9 of diamonds. Okay. And we've seen this already, that with the combinations formula, we're going to use the formula a lot and quickly be able to change 10c6 to 10 factorial over 6 factorial 4 factorial. These two, oh yeah, always add up to the number on the top. So if you had 82, choose 11. You could quickly say, I know this is 82 factorial over 11 factorial, and the other one would have to be 71 factorial. Because the bottom two have to add up to the one on the top. Oh. So one place that typically comes up in combinations is in the game of poker. Some people have played poker, some people have not. The way that the game of poker works is you get 5 cards. So if I randomly take this deck of cards and go 1, 2, 3, 4, 5, that makes a poker hand. And in this poker hand, we happen to have gotten the 6 of spades, the 10 of hearts, the queen of spades, the king of diamonds, and the 6 of diamonds. Be very, very amazed, because how many different 5-card hands are there in poker? Well, if you have 52 cards and you choose 5 of them, that will tell you how many poker hands are in total. And if we go to our calculator and figure this out, can someone check it on their calculator? This is like one of these numbers that I have close to memorized, but not quite. 2 million something, 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 980? I don't know. $598? And then is it 980 or no? Close? Oh, 960, see? So close to have it memorized. 2.6 million almost. And so what I just pulled out, okay, you will probably never, ever see this poker hand again in your life. The chances of me getting this exact poker hand were 1 in 2.6 million. Unfortunately, for those that play poker, is this a really good hand? Kind of like, not that good, right? I've only got one pair. It's not the greatest poker hand in the world. But my chances of getting this one are exactly the same as my chances of getting like this exact one with the 6 of diamonds, not just any 6, and the 6 of spades. Chances of getting this are exactly the same as a royal flush in hearts, where you have 10, jack, queen, king, ace in hearts. But in poker, that hand is seen to be much, much better than this one, and really, really rare. So we're going to look at those kind of combinations today as well. Committee questions, right? A committee of 2 boys and 3 girls is to be selected in a class of 15 boys and 8 girls. Does the order matter, right? If you were going to be put into a committee or you're in a group, right? I'm going to do a group project for permutations. And I tell you that your group is, we need 2 boys. Oh, perfect. Here we go. 2 boys, 3 girls. That's your group. And Sherelle says, I don't want the group where you picked Charles and Noah. I'll say, okay, I'll make a new group. You can have Noah and Charles. Or you're like, okay, that's good. Well, it's the same group, right? Did the order matter? No, it doesn't matter. You're like, I don't like our group because you picked Charles and Noah. And you're like, I'll switch it. I'll pick Noah and Charles. Okay, that's better, right? It's still the same group. So we have to imagine on committees and this, the order doesn't matter. So it becomes a combinations question. But in this combinations question, we have 2 different decisions to make. We have to choose our 2 boys. So that would be 15 choose 2. And then we have to choose our 3 girls, which will be 18 choose 3. And every group of 2 boys can go with every group of 3 girls to make a different group, right? Because all of a sudden, if I said, okay, I'll take out Noah and Charles and I'll put in Aaron and Parker, that would feel like it was a different group. So in this case, we have to multiply all the groups of 2 boys together with all the groups of 3 girls to make all the different committees possible. So let's say we have 20 people in the class, and I want to make 3 different groups, and I'm going to make one group with 8 people, one group with 5, one group with 7. How many ways can this be done? Now this is an interesting question because it's sort of similar to the boys and girls question. You've got different decisions to make. One way you could think of it is you could say, okay, my first decision, who's going to be in group A? Well, order doesn't matter in group A. I have 20 people. I need to choose 8 of them to be in group A. Am I done with my decisions? No. This will get multiplied by now I have to make a decision who will be in group B. Why will I not write 20 choose 5? I need 5 people for group B. Why can't I write 20 choose 5? I already took out 8 and put them in group A. Does that make sense? So there's only 12 people left, and I need to choose 5 of those. Okay? Now, if you're still in the class, and you haven't been picked yet, I'm hoping you're not saying, I wonder what group I'm going to be in. They're in group A. They're in group B. I haven't been assigned yet. I wonder what group I'm going to be in. What are the numbers in this last one? How many people are left? 7. How many people do I have to choose to be in the last group? 7. There's only going to be one way that happens. 7 choose 7 is 1. If you're one of the last people and you're still wondering what group you're going to be in, I feel bad for your group because you're probably not going to help them in the project very much in the end. So we get this as an idea. And you'd have 20 choose 8 times 12 choose 5 times 7 choose 7. The question you have to ask yourself, and this is the hard part about permutations and combinations, is you often have to ask yourself, is my logic, does it work? If this is supposed to count all the possibilities of group A, group B, and group C, does everybody have a chance to be in group A? Yes, 20 choose 8, that counts all the different groups of 8. Everybody has a chance to be in group A. They also have a chance to not be in group A, which then gives them a chance to be in group B. And you could not get, everybody has a chance of not getting chosen here or there, which would land them in group C. But someone inevitably might ask, well, someone should type this into our calculator for us. Someone might ask, well, what happens if we chose group B first, right? And then I chose group C and I left group A to the end. So this would mean I do 20 choose 5 first, and then I would have 15 left, and I would choose 7 of them, and then 8 choose 8. Those numbers look different. Wouldn't you agree? Should the answer be the same? Should that make a difference which group I pick first? It shouldn't. So this is something that you might do in math. You might say, I'm going to plug both of these into my calculator and find out, are they the same or are they different? They end up being the same. Whew. Okay? And we can see that they're the same. I'll move these down just a little bit here. What is 20 choose 8? It's 20 factorial over 8 factorial 12 factorial. Times by what's 12 choose 5? 12 factorial over 5 factorial 7 factorial. And 7 choose 7, I'm just going to write that's 1 instead of having to write out the formula. Can you see that if you multiplied these out, these 12s would cancel out? Leaving you with 20 factorial over 8 factorial, 5 factorial, 7 factorial. If we did the same thing underneath this one, we'd have 20 factorial over 5 factorial, 15 factorial, times by 15 factorial over 7 factorial, 8 factorial, times by 1. Here the 15s would cancel out. And you can see you get the exact same answer. And when I look at the answer that I got, can anybody think of a 20-letter word that has repetition, 8 of one letter, 7 of another letter, and 5 of another letter? Probably not. But the other way we could have solved this question is we could think, if I lined the students, all 20 students up from shortest to tallest, and then I took eight A's, 5 B's, and 7 C's, how many different ways could I arrange the letters in that word? Well, it's like a Mississippi question. There's 20 letters, would normally have been 20 factorial ways. But now we have repetition, we have 8 A's, 7 C's, 5 B's. And if I think of all the different words that I could spell with those, and then put those words on the people standing from shortest to tallest, that would make all different unique groups of A's, B's, and C's. So this is the interesting thing about permutations and combinations. Depending on the logic that you apply to the question, you could solve the same question in more than one way. Okay, getting back to poker hands. So we now want to count how many poker hands have no clubs. If I wanted to randomly pick 5 cards, 1, 2, 3, 4, 5, could I get no clubs? Yes. Did I get no clubs? Oh, I did bad. I got 3 clubs. Man, how could I, if I wanted to take 5 cards out of here and get no clubs, how could I guarantee that I could do that? Take the clubs out, right? Take that club out, right? Be ready to be amazed. Okay, here's another club, all right. There we go. Oh, a couple more. Oh, there we go. This is going to be random. Let's see if I can do this. 5 random cards. Be ready to be amazed. Okay, check them. Did I get any clubs? Amazing. Is it amazing that if I took out all the clubs and then randomly picked 5 that I wouldn't get any? Probably not that amazing. But does it make sense that I won't get any clubs if I take the clubs out? So how many poker hands have no clubs? Well, that would be like taking those 39 cards that are left and choosing 5 of them. This is a really pretty number, I think, if I remember correctly. Oh, I wish my calculator was faster right now. Did someone do it on their calculator already? What is 39 choose 5? It's a, oh, of course now it works. Equals, is it 5, 7, 5, 7, 5, 7? Yeah, that's a pretty looking number, don't you think? 575,757 poker hands have no clubs. And we could count that by imagining, hey, if I first take out all the clubs, I'd have 39 cards left. Then if I choose 5, guaranteed not to have any clubs. All right, so we'll continue with this tomorrow.